Okay, we're just going to take a look at a kinematics example, and we're going to take a look at the relationship between distance, velocity, and acceleration. All right, and how we differentiate to get to those places. And we're going to take a look at it in relation to a graph. So I've used Angry Birds as a model, and I'm going to use this equation here to just sort of model what's going on with the Angry Bird. And distance, I mean, if we put a set of axes in here, we have a time on the x-axis and distance on the y-axis, and the bird's just moving through time, and he's further away from the ground as he goes, and then coming back down to the ground and trying to hit the target. Now, let's just say if for an example, at initial time of 0, we're going to have a distance of 5 meters. That's pretty obvious. And so that's just what we look at. Now, let's just say we want to know that in any particular instance in time along this graph, anywhere here, we want to know how fast, what the speed of the bird is traveling at. And so we're going to take a look at how this relates to speed. All right, so we've got our graph, just a very basic time distance graph. This is our time and this is our distance, and we know that our distance is equal to 5 plus 20t minus 2t squared. Now if we differentiate that, we will create speed in kinematics, which we often call velocity, and if we differentiate this, we know that we're going to get 20 minus 4t. It's a straight line. And it's going to look something like this. If we continue, we can make negative axes as well. This is our 0. And we know that in relation to this, we've got a max point here. And so that's going to be where our graph crosses the x-axis at 0. And basically, we're just following along. We know that at this part of the graph, the gradients for tangents are all positive. So our line that we create from here has to be above the x-axis and then hit at 0, and then after that stationary point, gradients are all negative, so below the x-axis, which is here. And so this is our graph for our speed, for velocity. And the thing about speed is that if we took an initial time 0 for velocity, all right, in other words, we put in 0 for t here, we would get a velocity of 20. And what does that mean? That means at the very beginning here, the speed is 20 meters, and it's just say per second, if that's our units that we're using, 20 meters per second at t is equal to 0, which basically tells us that at that point, when you have a positive speed, that tells you that you're moving away from something. Moving away. And that makes sense because if we take a look at our graph over here, we know that the bird is traveling away from the ground, going further and further away from the ground until our stationary point. And that makes sense. And if our speed happened to be negative, then that tells us we're moving towards something. And that makes sense. Again, towards the ground. Because after, and by the way, this would be 5 meters here, after this point, as we move here, gradient is negative. That means we're moving towards the ground. So that makes perfect sense. Now, how does this relate to acceleration? Okay, so this is our speed graph, and our speed is again also called velocity. And velocity has a formula that we've just discovered, minus 4t, and it gives us a straight line. Now, if we take that one step further and we differentiate the expression again, we get acceleration. And in this case, when we differentiate again, we get this, a formula where acceleration is negative 4. Now, what does that mean in the context of our straight line graph? Well, it basically means we're going to have to extend this down to negative 4, and we get this straight line across like this at negative 4. Well, what does that even mean? Well, it basically means we have a straight line here, so that we know that the gradient of the straight line is a constant. And in this case, It's a constant negative 4. Now, acceleration, when it's negative like this, simply means that you're slowing down, that your speed is decreasing. And so in this graph, this bird that is flying through the air is decreasing at a speed of negative 4, and again, if it's meters per second or whatever, and with acceleration, it's square units of time, so square seconds, so meters per square second, or second squared, or whatever you want to say it. This is how the bird is traveling over time. Speed is actually decreasing by 4 meters per square second. And that's represented in this graph here, and we can obviously make sense of that. When we differentiate, again, we know that we're going to get negative 4, and that what that tells us in the context of the question.